All right, elimination substitution. There's always that one person who really likes substitution. I am not that one person. But we're going to go over both methods just to refresh our memories. Today we're going to talk about substitution. Substitution is where you solve one equation for one variable, and then you substitute that expression into the other equation, and you solve. All right? You're going to have fractions, you're going to have decimals, you're going to have no solutions, all that good stuff. That's all a possibility. It all could happen. But the beauty about solving equations is what can you do with the answer that you find? You can check it. You can plug it back in. You are going to solve systems of equations right now. You're solving two. All right? You might have squares and stuff in them, and that's okay. But you will get your answer, and you're going to write your answer as an ordered pair. Right? Your answer should be written as an ordered pair. That means we have an x value and a y value, x comma y. You should check your answers, plug it back into both equations to make sure that it satisfies both. Just because it works in one doesn't necessarily always mean it's going to work in the second one. So if you are talking here, guys, and if we graphed, anytime you graph two equations, their solution is where they would cross. So if you have an equation that has squares in it, it might have two solutions where it's going to cross twice. But if you have a question like this, all right, it says solve the system of equations. We're solving using substitution. On your test or your quiz, it'll probably say solve. You might have one that says to do it in a specific manner. Or you might have, if they just say solve, then do what you like better, substitution or elimination. But we're going to practice both. In a case like this first example, okay, obviously elimination is the easiest. You just cross off the y's and solve from there. But it says to use substitution. So you can solve either equation for either variable. It doesn't matter. There's 4 different ways you could start solving this. I'm going to just take the first equation and solve for y. So if I solve for y, I'm going to subtract x from both sides. Does everybody understand what I just did there? So this now says y equals, you can say negative x plus 4. You could say 4 minus x, however you want to. I'm just going to write 4 minus x. So what I'm going to do with this value here is plug it into the second equation for the y. So you're solving one equation for one variable and then plugging that expression into the other equation. So I have, now I'm going to solve x minus, instead of y, I found that y is the same as 4 minus x equals 2. What do I have to do with that negative sign outside here? I have to distribute it. Good. So this becomes x minus 4 plus x equals 2. Can I combine like terms? Yep. So x and x gives me 2x minus 4 equals 2. Now what? Add 4 to both sides. You get 2x equals 6. Divide both sides by 2, and x equals how much? X equals 3, all right? So now that I know what x equals, how can I figure out what y equals? We're going to use something called back substitution. You're going to go back and substitute in one letter to solve for the other one. Does it matter which equation that I use to plug back in? Yes or no? No, doesn't matter. I'm just going to go to the top one. So I'm going to say, okay, fine. I'm going to plug in x to my original top equation. So I have x plus y equals 4. I'm going to plug in 3 for x. So 3 plus y equals 4. Everybody with me? Yes? Okay, so subtract 3 from both sides. And I get y equals 1. How do I write my answer? As an ordered pair, 3, comma 1. Now we should go back and we should check to make sure. You have to plug back into both equations. If you want to write the check down, that's fine, so you can actually see the left-hand side equals the right-hand side. Or this is pretty basic, you just put it in, use your head. If I plug in 3 for x and 1 for y, in the first equation, what's 3 plus 1? 4, so we're good. If I use x is 3 and y is 1 in the bottom equation, I have 3 minus 1 equals 2. Yes? So we're good to go. We know that this solution works. All right. And obviously it tells you what's going on here. Like this is a 2-solution case, but it's not always going to say that. It'll just say solve. So we notice here, how is this one a little bit different? It's got a squared to it. What do you know when variables are squared? What do you know about their answers, their x values? There's usually two of them, right? So again, this is telling us to solve using substitution. You guys can solve for whatever variable you want to. I like to choose the things that are the easiest. So I think that this equation on the bottom looks like the easiest one to get a variable by itself. Doesn't have a coefficient or anything like that. So I'm going to subtract 2x from both sides. I have negative y equals negative 2x minus 1. You could have written negative 1 minus 2x, doesn't matter. And then I'm going to divide everything by negative 1. Agreed? So I get y equals 2x plus 1. So I'm now going to take this expression and I'm going to plug it into the top equation. Use one equation to solve for that one variable, and then whatever expression you get, plug it into the other one. So in this case, I have x squared plus 4x minus, instead of y, I'm going to write 2x plus 1. I'm going to leave it in parentheses because I know I have to do well with that negative sign. Distribute it. So you have x squared plus 4x minus 2x minus 1 equals 7. Can I combine like terms and move 7 over? Okay, so I'm going to subtract 7 from both sides and combine like terms here. So I'm left with x squared plus 2x minus 8 equals 0. What kind of a problem does it appear that I have? A factoring problem. So when I factor this, what times what gives me a negative 8 when I multiply, but a positive 2 when I add? X plus 4, x minus 2. Good. So when you set each of those parentheses equal to 0, you get x equals negative 4 and x equals positive 2. So in this case, I came out with two x values, which means I now have to substitute back in and find the two what? Y values. Okay, good. Now again, you can go back to either original equation. I like to do the least amount of work possible. So I'm going to substitute into 2x minus y to find out what my y value is. So I'm going to say, okay, so 2x, I found out x was negative 4, minus y equals negative 1. So 2 times negative 4 is negative 8, minus y equals negative 1. We're going to add 8 to both sides, correct? So negative y equals 7. So what does y equal? Negative 7. So I have value, when I have negative 4 as my x value, my y value is negative 7. Now, you don't have to check. I just think it's in your best interest because first of all, you need to make sure that you didn't make any mathematical errors. You want to make sure you didn't make any math errors, and you want to make sure that your values make both equations true. We'll check it 1 second. Let's go back up here. Same thing. I'm going to use the exact same equation, 2x minus y equals negative 1. I'm going to plug in my other x values. So 2 times 2 minus y equals negative 1. 2 times 2 is 4 minus y equals negative 1. I'm going to subtract 4 from both sides. So I get negative y equals negative 5. So y equals what? Positive 5. So over here, I had 2 comma 5. So we have two answers here. So if I were to graph these two equations, they would intersect at those 2 points. So let's plug back into both equations for 1 second and just make sure that they both work. So here I have x squared, I'm going to use negative 4 squared, plus 4 times negative 4 minus a negative 7. Does that give me positive 7? Well, think about this. Negative 4 squared is 16, minus 16, minus a negative gives me plus 7, right? Equals 7. What happens with 16 minus 16? Cancel, so 7 equals 7. You're right. Now go to the second one. 2 times negative 4 minus, excuse me, a negative 7. Does it equal negative 1? 2 times negative 4 is negative 8. Minus the negative is plus. Negative 8 plus 7 is negative 1. Does it equal negative 1? Yes. So you know that this answer is correct. Takes 2 seconds, guys. Just plug back in and make sure. Make sure you didn't miss a sign or anything like that. All right, we're going to do the same thing on the other side. I'm going to use my 2 and my 5. So I have 2 squared plus 4 times 2 minus 5. Does that equal 7? Well, 2 squared is 4 plus 8 minus 5. Does that equal 7? What's 4 plus 8? 12. What's 12 minus 5? So 7 equals 7. It works. So my second one would be 2 times 4, right? Minus 5. Does it equal negative 1? No, not 2. I'm sorry. It should be 2. What's 2 times 2? 4. 4 minus 5. Does that equal negative 1? Yep. So you found out that both of these solutions satisfy the equation. They both work. These 2 places on a graph that's where your picture would intersect. Yeah.
Doesn't matter which one we plug it into?
You have to plug it into both.
Oh, you do?
Yeah, especially that's a good question. Especially when we get to the multivariable ones where there's 3 equations and 3. Sometimes you'll get the ordered triple, which is the x, the y, and it'll work in 2 of the equations and not the third one. They're tricky like that. All right, moving along. Again, I know you guys can see it tells you what's going to happen. On your quiz, it's not going to. You're just going to have to figure it out. Now, again, if it just says to solve, you could do whatever you want. Substitution or elimination. This section is just substitution, so that's what we're working on. Obviously, it would be easiest to just eliminate the y's and then move along that way. But if you don't, whatever, we'll work on it. But which equation do you guys want to solve? For which variable? Or do the top equation solve for y? It's probably the least amount of work. So just add x to both sides. So you have everywhere you see a y in the second equation, you're going to plug in 4 plus x. All right, so I'm going to replace this x squared plus, instead of y, 4 plus x equals 3. Okay, so x squared plus 4x. Hold on a second. Why did I write this like that? This should be 4. Okay, sorry. So plus x. If I bring this 3 over, you guys agree with me that I have plus 1 equals 0? Okay, so it's a factoring problem. Are there factors of 1 that are going to multiply to give me positive 1, but add to give me a 1? Anybody? No. That's to multiply to give me 1, but add to give me 1. Is that going to work? No. So if you have a quadratic that doesn't factor, what do you have to use? Quadratic formula, okay? So if I have negative b, I'm going to have negative 1 plus or minus, right? 1 squared minus 4 times 1 times 1, all over 2 times 1. So negative 1 plus or minus, I have 1 minus 4 divided by 2. If I simplify this a little more, negative 1 plus minus, what's 1 minus 4? Negative 3. What's the problem here, guys? There's a negative underneath the radical. Could I find an answer here? There's no real answer. Very good. And there's no real answer. And when we talk about this, guys, your solutions, when you get your xy value, it is a real number that is on a coordinate plane. So if you get to a factoring problem that doesn't factor pretty, what's your answer? No solution. The reason why it is no solution is because you get an imaginary answer. It doesn't factor. Everybody see that? Okay. Good job. Good job. All right. You will have word problems, guys. And the only way we get better at word problems is practicing them. We're talking about systems of equations now. How many different variables have we discussed? 2, right? There's been x's and y's. When you have a word problem, and you'll get better at this as you work on it, stuff stays together. Like they'll talk about ticket sales, an adult ticket and a child's ticket. So what would your 2 variables be for adult tickets and child tickets? X would be adults, Y is children's, right? Then they'll give you a price. They'll tell you that the adult costs this much, the child costs this much. So the type of ticket plus the type of ticket stays together. The price plus the price stays together. the types of things, if you're talking about hamburgers and french fries stay together, french fries and french fries stay together. Think of it that way. So when you look at this problem, it says a total of $12,000 is invested into two funds. How many funds? Two. What could we call them? X and Y, all right? How much money total was put into these two funds? 12,000. So does it make sense that X plus Y equals 12,000? Right? You see where I got that? Now the next thing says that the two funds pay interest rate. One of them pays 9%. One of them pays 11%. Does it matter where you assign the 9 to and where you assign the 11 to? No. But what do you notice here? You have a 9% interest, you have an 11% interest, and then you have a total amount of interest. So do you see how those three numbers, those three things should stay together? I'm going to say that my X is 0.09, the percent one. Doesn't matter, you can make X 0.11. And then I'm going to make my Y my 0.11. And what is the total amount of interest that was accrued? 1,180. Now, again, this type problem, I personally would use elimination. But this we're using substitution, so we're going to solve. I like to solve for Y because we're used to solving for Y. So if I were to get Y by itself, do you guys agree that this is the expression that I would plug in to that spot right there? Yeah? Okay. That's fine. Now, we don't have calculators on our desk. I'm not sure about what we're going to do calculator-wise. So I don't really like to use decimals. How can I get rid of these decimals? Could I multiply the entire equation, the left-hand side and the right-hand side, by 100? Yeah. What would that do? It moves the decimal place over. So this is the same as saying 9x plus 11y equals 118,000. You can do that with anything, guys. And it doesn't have to be if you have two equations and one you want to multiply by 10, one you want to multiply by 100. That's fine to move decimal places, just as long as you do it throughout the entire thing. So now I'm going to go through and I'm going to replace y. I'm going to say 9x plus 11 times. Instead of y, I'm going to say 12,000 minus x. And then I finish out my equation. And now this is just a basic algebra problem. We have 9x, and then I distribute. What's 11 times 12? What is it? How much? Okay, so plus 132, then just stick your zeros with it. Minus 11x equals 11800. Can I combine anything? Okay, so what's 9 minus 11? Negative 2x. Then what can I do with this 132? I can subtract it. So I'm going to subtract 132,000. 132,000. What's 118 minus 132? So I have negative 14,000, and then I divide both sides by negative 2. And I get x equals 7,000, all right? Now, I don't want this as an ordered pair. I have a word problem, so I want you to use your words. What does that mean, x equals 7,000? What does that mean? How much money was invested at what percentage? So you have $7,000 was invested at 9%. Okay, that's one part of your answer. Well, how much was invested at 11%? How'd you get that? Yep. Good. If 12,000 total was invested, and you know that 7,000 of it's already accounted for, then the leftover, 12 minus 7 is 5. So 5,000 was invested at 11%. Now again, a lot of times elimination is easier with stuff like that, I understand. But in first period, I solved for the other variable, and I got the same exact answer, just in a different order. I got the 5,000 first, and then we discovered the 9%. All right, does that make sense? Scooting along, all right? You guys can start your web assign as soon as we're done with this. You should be able to get a good bit of it done. Again, it's not until Friday, but so take your time. But I kept the explanation here because I want you guys to see this word problems. Once we have this set up, then you guys are like, oh, this is super easy. But sometimes it's hard to set up. But I want you to understand this question is asking, right, tells you a whole bunch of information, and we'll talk through it. But it's asking for when the business will break even. Does anybody know what that means? When you say, man, I wonder when they're going to break even.
When you make however much you invest.
Perfect. When you finally break even, it's all the money that you've invested into your company, you have made that back. You haven't made any money yet, but you made it back. When you are finding the equilibrium point, or when something breaks even, it's when one equation equals the other side. So let's read what this says. It says a small business invests $10,000 in equipment to produce a new soft drink. If I invest $10,000, is that my cost, or is that money I'm making? That's your cost, right? Part of my cost for my business is I had to take 10 grand out of my pocket, okay? Then it says each bottle of the soft drink costs 65 cents to produce. So that's adding to my initial 10,000, right? So it's 65 cents for every bottle that I make. Do I know how many bottles I made or I need to make? No, that's my variable. All right, but then on the other side, it's sold, each bottle of soda is sold for $1.20. Is that my cost, or is that money I'm making? Is that my revenue? That's your revenue. That's the money that you're making, $1.20 per bottle. So the cost is initially what I put in to get this thing going and manufactured, and the revenue is what I'm making back. When they ask you for the break-even point, what do you know that those two things have to be? The same. They have to be equal. So if you were to solve this, it would be 10,000 plus 0.65x equals 1.20. If you want to get rid of the decimals, what would you multiply the entire equation by? 100. If you wanted to do that, you're more than welcome to, but you don't have to. But in this case, we don't have two different variables. We have two different things that we're talking about. We're talking about cost versus revenue, which is what you're making. So if we're going to solve this, you have 10,000 equals, I have to subtract this 0.65, right? So what is $1.20 minus 65 cents? 0.55. And then what do? I'm going to divide by 0.55. Again, you guys can't do this in your head, so go ahead and grab your calculators. But I get x equals, what's 10,000 divided by 0.55? $18,181.82. All right, now we're talking about a word problem, so I want to answer this correctly. What does X represent? The bottles. So about how many bottles do I need to make in order for me to break even and then start making money? About 18,100 and what? 82 bottles, correct. If I don't make that 182nd, if I only make 181, did I make any money? No, you have to make that whole bottle. Does that make sense? All right, last one. I messed this equation up last night when I was writing it down, so just disregard it. We'll work on more like that. All right, I look at this problem and I see a bunch of, what do I see? I see fractions. Do we love to work with fractions? Yes or no? No. Okay. So, in a case like this, You can deal with this exactly as it is, working with fractions if you want to. All right, substitution is a little difficult when we have fractions and stuff like that, but you could solve that second equation for y, right? Move the 3/4 over, whatever. That's absolutely fine. I'm going to get rid of the denominators and then kind of solve by elimination because that's going to lead us into our lesson for tomorrow. How do I get rid of those fraction denominators? Okay, I like what you're thinking. We're going to multiply. We're going to multiply by something that will allow us to get rid of our denominators. You can multiply an entire equation by anything as long as you multiply the left-hand side and the right-hand side by the same amount. So Mikey's telling us 4, and I agree with that because when I multiply, when I distribute this 4 here, 4 times 1 is 4, right? And then 4 divided by 2 gives me, so I have 2x. Now I distribute the 4 here. What happens when I multiply 3/4 by 4? The 4's cancel, so I have plus 3y equals, what happens when I multiply 4 times 41 over 4? It just equals 41. Is that a lot more manageable to look at? Yes. Okay, we could do the same thing on the bottom. What can I multiply the entire equation? It's got to be both sides of the equal sign to get my denominators to cancel out. 4. Okay, good. So when I distribute here, I have 3x. When I distribute here, I have minus 4y. And when I distribute here, I get what, 16? All right, now, the way that this is now set up, this does not lend itself to substitution because you'd have to solve for one variable and then you're going to have to divide by the coefficient. It's not great. Many of us are much more comfortable with elimination. So this is what we're going to do tomorrow. What does that mean, elimination? You want to multiply one or both of your equations by a number that will create exact opposite coefficients. So in that case, we can get rid of x's or we can get rid of y's. It doesn't matter. You'll get the same answer. You'll solve for one variable and then discover the other. That doesn't matter. But do you want to get rid of x's here or you want to get rid of y's? Anybody? Let's get rid of x's. What would I have to multiply the top equation by, the bottom equation by? What do you guys notice between 2 and 3? What would be the coefficient that would cancel out? 6, all right? So I'd have to make one of them positive, one of them negative, correct? So if I multiply this top equation, I'm just going to multiply by 3. And then I'm going to multiply the bottom equation by what? Negative 2, all right? Some of you would want to say, well, I'm just going to do y's because already one's positive, one's negative. We'll just multiply by 3 and 4. You could do that. But when you distribute, when you multiply, when you're doing elimination, you have to distribute through the entire equation, the left-hand side and the right-hand side. So now numbers are going to get a little gross. And you guys started off with fractions. That means your answer needs to be in fractions. So 3 times 2 would give me 6x. 3 times 3 would give me 9y. And then 3 times 41 gives me what? 123? So now on the bottom, I have negative 2 times 3 gives me negative 6x. Negative 2 and 4 gives me plus 8y. And negative 2 and 16 gives me negative 32. Everybody agree? Now with elimination, once you create that coefficient that is the same number but opposite signs, when you combine, what happens to them? They cancel out. So what do I cancel out here? 6x and negative 6x? Okay. Then add down. What's 9 and 8? 17y equals, what's 123 minus 32? 91. All right, and then divide both sides by 17. So I get y equals 91 over 17. Does that simplify pretty? No. Is that going to be amazing to plug back in and figure out what x is? No. But we're going to do it. That's okay. So I found out that y is 91 over 17. If you guys put that in your calculator, you will not get a terminating decimal. So you cannot use approximations to solve. You cannot do that. But which equation would be probably a little simpler to solve for your x value? So plug that y back in. Which one would be a little simpler, you think? The bottom one? Okay, so I have 3/4 x minus, instead of y, I have 91 over 17 equals 4. Agreed? Okay, so this is 4 over 1, right? So I have to move the 91 over. I'm going to add 91 over 17, so plus 91 over 17. Well, if you're going to add fractions, guys, what do you have to have? A common denominator, so change this to 17ths. What's 17 times 4? 68. So what's 68, 91? Okay, so I have 159 over 17. Now what's the last step? Multiply by 4 over 3. So multiply by 4 over 3. So x equals what? I don't expect you guys to do all this in your head. What's 159 times 4? So 636 over what's 17 times 3? What is it?
51.
51, okay. And does that reduce? 3 goes into both of them. So this reduces to x equals 212 over 17. So your ordered pair, guys, is 212 over 17, comma, 91 over 17. Yeah? Okay. So then what would we do with that to make sure that we were correct? Plug it back in. Now, in a case like this, if you had a problem like this, you guys would have a calculator. That would waste a lot of time. But you would just plug it back in. You'd say 1/2 times 212 over 17 plus 3/4 times 91 over 17. Does that equal 41 over 4? So use your calculator, plug it in, check. Then you would say, okay, I have 3/4 times 212 over 17 minus 91 over 17. Does that give me 4? What's 212 divided by 4, guys? So this becomes 1, this becomes 53. So look, you have a common denominator here. What's 53 times 3? 159, you said? All right, so 159 minus 91 is what? What's 68 divided by 17? 4. Does 4 equal 4? There you go. You guys can you can do the basic math of checking, but this one does work. Is it pretty? No. Are all of your answers going to come out to nice, beautiful whole numbers like 3, 2? No. You guys will have fractions in your problems. But you can convert to decimals if they terminate, like 3, 1/2 or something like that, fine. But something like this is not a terminating decimal, so you need to make sure that you do not use decimal approximations. All right, sound good?